Hi everyone, welcome. I'm pleased to introduce Narvaez from MongoDB. He's a senior architect at MongoDB. He enables companies to build the next kind idea. He has been organizing a OC MongoDB meetup for 5 years, and he enjoys traveling, testing craft beer, and he hopes to become a master in Cicerone one day. He'll be presenting a talk titled Serverless Architectures with AWS Lambda and MongoDB Atlas. Please help me welcome.
Thank you. Thanks everyone. So just for the ones that just arrived, for those that just arrived, I'll be raffling a couple of these guys, especially branded MongoDB Cloud amigos. So go to my Twitter @Narvaez and retweet this particular tweet. You have to do this. Retweet. Retweet it. And then at the end, I will draw 2 winners by going to this page and simply picking a random tweet. Oh, there you go, Subhash. All right. And this was an awesome episode. I just thought it was a perfect analogy of classic on-prem IaaS versus serverless, right? I'm Jon Snow, that's it. All right, so today we're going to learn about serverless architectures with Lambda, MongoDB Atlas. I do want to do a hands-on demo, present a very simple microservice API, and if we have time, also a basic web app, a mean stack or Express Node.js app, all running serverless. My intent is that you learn something that you can apply right away. So I'm not going to show you a big, gigantic project, slides. I'll show you something working. And we'll talk basics of serverless and Lambda and how to make it work, particularly with MongoDB Atlas. There's a few things that I want to show code-wise that will make sure that the connections are fast and cached and so on. Okay, so let's dive right in. So I think as developers, we all think about where our code will run, right? And some of us have gray hair and may have started back in those days. But today, most applications are probably now running on containers, right? I think we've heard containers in a few of the previous talks. And what we realized, right, we didn't need virtual machines anymore. We could now run just the operating system services and libraries in a Docker container and then push those throughout the delivery pipeline, right? Now we're entering another computing paradigm called serverless, right? Or functions as a service, where now I don't even have to worry about creating a container and making sure all the dependencies are there. Now I just upload my code. Literally, I just upload my functions, pieces of code, into my cloud provider, and they will take care of hosting that in a container, raising it for me, and just scaling it as needed. Okay, and that's where the 3 cloud providers are really focusing on, with of course AWS Lambda being the leader, but Azure and Google Cloud also now have their versions. It's called Azure Functions and Google Cloud Functions. And I believe Google Cloud Functions might still be beta. I'm not sure if it still is, right? Okay, so it still is. So Azure is GA, AWS is GA, Google is still in beta. So serverless is real. Last year, I'm sure some of you followed the ThoughtWorks technology radar, and last year it jumped 2 notches. It went into assess first in April, and now into trial, which is I think 1 notch before basically adopting it for real. So it's definitely here and definitely being used in many places. Here's a slide from AWS reInvent last year that talks about the types of use cases are common for serverless applications. And interestingly enough, many of these are also great use cases where we have, obviously customers running MongoDB, right? These kinds of use cases. For example, did you know that the Cisco e-commerce platform runs on MongoDB? And it runs, processes billions of dollars, basically e-commerce for Cisco. Do you know that Vivint who is one of the leaders in smart home and IoT use case, is fully running on MongoDB and has a large-scale geo-distributed cluster across the US and Europe, connecting all kinds of IoT events from your home devices. Do you know or guess when you think would be the busiest time for an IoT smart home company, or rather when they get the most load on their servers?
Evening.
Evening?
Or wake up, probably on Christmas Day.
Close. Halloween. So apparently in Halloween, when trick-or-treaters go and ring your doorbell, that triggers an event. They actually have to they have to scale up and provision shards up front in order to make sure they can keep up with all those doorbells. So it's super interesting fact. Funny fact. And then there's also China Eastern Airlines that processes around 1.6 billion queries a day, also on MongoDB, and they are continually running Apache Spark to calculate fares. Like all day, it's just completely running and updating fares, and then serving 1.6 billion queries a day on MongoDB. Now, just to be clear, these use cases aren't using serverless, or maybe they are, so some of them they could be considering, and a business running definitely on AWS. Thermo Fisher, who spoke at reInvent last year also on presented their use case, they are using serverless. They're using AWS Lambda, and they are using it with MongoDB to process JSON data files and do massive parallel data processing of their mass spectrometry devices. Okay, so this is a really interesting talk. They're actually down here in San Diego in Carlsbad. So we'll probably have them speaking at another event here in SoCal for MongoDB. Just jump right into microservices. So I think we've talked about microservices before. We know that you do have containers. You probably do a container per domain, right? Maybe your customer's domain, maybe your orders and invoices domain, and so on. When you go serverless, you got to think finer grain, right? Now you got to think about the code handlers or the functions that are going to respond to events. And in the case of a microservice, those that will map to your resources, right? Like users as a resource, or users ID, which are users and routes, and then the HTTP methods, right? Post, put, get, patch, and so on, right? And then you will map those to handlers, in this case Lambda handlers, that in case will do logic and talk to MongoDB Atlas or your backend and so on. So a more fine-grained than what you're used to before. So let's imagine that we're going to build a single view, and for those of you that don't know what a single view is a very common type of project in MongoDB, where you have, let's say you're a very large company, like MetLife or another big insurance company. You have data from many independent systems, right? That could be mainframe, could be SQL Server, could be Oracle, etc. And you want to get a holistic view of your customers. What you do is that you would bring all that data into a MongoDB database, because MongoDB's flexible schema really caters for that use case, right? You could have a single document, a JSON document per customer with all of the data that you are interested in for your customers, and then build any kind of consumers on top of that, right? Let's say we have a very simple call center app that most of the workload is read-only, right? Because you're probably going to be querying, finding out, hey, tell me customers that are whose insurance policy is due to expire in the next 60 days or 90 days, so I can start reaching out, et cetera, et cetera. And maybe you do simple updates, right? Like I want to, when I talk to them, maybe update their cell phone or their email, or basic information, but not the complete data, because obviously the source of truth is in these systems, right? Not here. So let's say we want to build something like that. That's very simple. A pattern I really like for microservices is CQRS, right? Command query responsibility segregation. So let's say that's just for fun. We're going to build two APIs in Amazon API Gateway. We'll have your command API and your query API. The command, and each of them will have their own API keys, by the way, because you probably want to have different API keys for different consumers, different clients, maybe different customers. And then those will map to Lambda Functions. Just for fun, I wrote them in two different languages. One's going to be in Python, one's going to be in Node.js. By the way, Lambda supports Python, Node.js, C#, Java, I think that's it. The Python code is going to do majority writes. Why? Because when I change data, I want to make sure that it saves to at least 2 nodes in my Atlas cluster. And the reads will do secondary reads, so we can just scale up my reads. Okay? And then, because in a MongoDB Atlas cluster, we create our own VPC for security purposes, and you will be running your own VPC in Amazon. We have to peer them. Okay, we have to do VPC peering so that the Lambda functions can talk to the MongoDB Atlas cluster. Okay? So let's go build it. So first of all, I probably talked Atlas before, but I didn't explain what it was. So what MongoDB Atlas is MongoDB database as a service. We launched it about a year ago, only on AWS first, 3 or 4 regions worldwide. Today, it is available in all 3 cloud providers, in all regions as well. It is an automated service, completely on demand, completely elastic. You can add more replicas, you can add more IOPS, more memory, up and down, etc. as needed. It is, of course, secure. We just passed SOC 2 compliance. All deployments are highly available. You get a minimum of 3 servers so that they are, we will patch the servers automatically for you so the database will never go down, the database service. And also has the same enterprise backup service that we have with the enterprise version of MongoDB. Okay, so that's what Atlas is. So let's go set up one up. Now, I already set one up, obviously, for time purposes. And here it is. Big Data Day, LA, 17 customers. Just for fun, I'm going to go and create a new one, and we'll come back to this once it's created. So I'll choose on M10, which is the smallest size, confirm and deploy. Once it's running. That takes about 5 minutes. So here's my cluster. It's running on US West 2, Oregon. It's an M10. The reason why it has to be an M10, the M0 is free, by the way. The M10 costs you. It only costs you $57 a month, which is less than Starbucks, for what you could do in Starbucks. So the reason why we need an M10 is because we need to have VPC peering. And with an M0, you don't know which region the instances are running on. With an M10, you do assign it to a region. Okay? And obviously I need that because my Lambda functions are running also on an Amazon region. So there it is, my cluster. I'm going to show you the data. So this database has 1 million customer documents, around 1.19 gigabytes of data. Here's a sample document. I was telling you about bringing all the data for a customer together. So imagine that here's your customer called Willie Price that lives in DC. Here is their location and coordinates. That's the geospatial data. And maybe they have 3 insurance policies, a home policy, another home policy, another policy. As you can see, there's a lot of random data there, right? So I use the random data generator. So that's the power of MongoDB and the JSON documents, right? You can create very rich structured documents, right? Okay, so now that's ready. I use also mgenerate. mgenerate.js is an open source project from one of our engineers. Sorry for that. And here's a template for that file. So this is the JSON template that I use to generate those 1 million customer records. So you can just create this template. It's almost like a JSON schema, and push it through mgenerate. It'll generate billions, however you want, hundreds, millions, tens of millions of documents. I'm not going to run that because that can take obviously a lot of time. It has to go over the wire, but it's very simple, right? You call mgenerate. Oh, sorry. You call mgenerate, tell it how many documents you want, the template, and then use Mongo import to just push them into MongoDB. Okay. Now from the AWS side, I'm going to need to work with 4 services. First, IAM, which is where you manage all your roles and Lambda secret policies. Then VPC, where we'll set up the VPC peering, which we talked about. Lambda, of course, that's the main actor, for this demo. And then API gateway will allow us to have an API and routes and methods mapped to those Lambda functions. Okay? Let's talk about VPC peering. So I want to sort of walk you step by step on how both VPCs have to be peered. So here's screenshots from Atlas on both sides, on that side, and here's the screenshots from AWS. And then the lines in orange are AWS VPCs, as well as the CIDR block. And then the lines in green would be our VPC from MongoDB Atlas and in CIDR block. So when you peer them, you got to make sure that both are registered on both sides. And to show you that for real, here is my AWS console. And if I go into VPC, which I hope to find, and we look at peering connections, there's my local VPC, VPC 51, paired with PCX VPC. And if I go into Atlas, go on security, peering, there's VPC 51 paired with PCX. Okay? And it has a wizard, by the way. It's very simple to do. There's already a wizard that you would just go in and enter all your data about your AWS account and so on, and it'll be done. It's super easy. Okay, so now that we have the VPCs paired, I can now go and create Lambda functions. Now, before we go and show the example code, I want to explain this to you. And it's actually literally from Amazon's Lambda documentation that talks about how, really under the hood, Lambda in itself is just another container engine, right? It creates containers for your code and then destroys them when they're not needed. So just to kind of literally read the documentation, AWS Lambda maintains the container for some time in anticipation of another Lambda function invocation, and the service will freeze the container after a function completes and toss the container for reuse. However, if Lambda chooses to reuse the container, and it has the following implications. Any declarations in your Lambda function outside the handler code, which is the entry point, the actual function, will remain initialized, providing additional optimization when the function is invoked again. That's great for us, for database connections, because you all know that database connections are, one, costly to open, and they require state, right? So that's where we can create our MongoDB Atlas connection outside the handler, such that it'll live across calls while the container is alive. Okay, so here it is. In Python, what I would do is literally go and read my Atlas connection string from an environment variable, create my Mongo client and connect, and then inside the handler function, this is the entry point, you would use the Mongo client. This is how you literally declare that as a global variable, right? Reminds me of the 80s. And in Node.js, it's a little different. We have to set this flag, context.callback waits for an empty event loop. Here's the article. By the way, everybody's going to get the source code, so I'll get up to, by the way. And then just declare a cache DB variable, and then test if it's cached, and if not, go and actually make the connection and cache it. And then that will allow you to make sure that any subsequent calls will be fast, right? When you develop in Lambda also, there's emulators. You don't have to always be working directly against AWS. You can install some emulators and run locally and before you're ready to deploy. So there's a couple of Lambda emulators for Python and Node.js. And when you're done, it literally is as simple as taking all your source files, putting them in a zip file, and uploading them to Lambda. It's literally that easy. And that's what they will look like. So let me go into the console. Here they are. And let's go into Lambda. And there are my functions. Okay? I call them BDDLA17 customers patch, customers get, customers renewals get. One's in Python, two are in Node.js. Let's click on the one in Python. Oh, actually, let's click on the one in Node.js because you can see the code. And there's the code. Now you can actually edit the code in line, or it's better to do an upload of a zip file because there will be dependencies, right? You have to bring in the Node.js driver from MongoDB or the Python driver from MongoDB and so on. And after the code is uploaded, you can also set global variables, or rather environment variables. Like here's my cluster URI connection. That's my MongoDB Atlas connection. To get that, I would simply go into my cluster here and say connect. connect your application, and there's my Atlas connection string. Okay, very simple. Oh, and once I put the function, there's a few other things that we need to set up, which is the VPC that is peered. That means that this Lambda function will run under that VPC, which is peered with Atlas, so they can talk to each other. A few subnets and a few security groups that for permissions and traffic. Okay. Once that is done, in API gateway, I can go and define my API and define routes. So like in this example, I'm creating an API whose routes are API v1 customers, and then I have a get method, and that get method is mapped all the way to my Lambda handler function right here. Okay, and the same will be for any of these other routes that I have. I have a renew in 30 autos, so it will tell me only customers whose insurance policies will renew in 30 days, and only for auto policies. This one's for anyone that reads in 60 days. This one is by ID, and so on. So you can create your API any way you want. Then you deploy it to get an actual production URL, like over there, and create API keys, so you can distribute those to your clients. And let's go test them. And with that, we'll use Postman. I already have it here. Let's try the customers. Actually, let's try this one. Here we go. Now, that's taking a little bit of time. Why do you think that is?
Firing it up, firing up the container.
Exactly. It's firing up the container. There is. How long did it take?
Should show it.
11 seconds, right? I don't know if you can see that. Let's see 11,000 milliseconds, so 11 seconds. And let's run it again. Much better. 482 milliseconds. Again, 348, 408, 78. This one's faster, the ID is just a single document. 308, 62 milliseconds, there you go. Fast. Okay? This one will take long again. Why? Because it just happens that these two are mapped to one function, which is one container. These two are mapped to another function, which is another container. Okay? And the last one is mapped to the Python function. Okay? Now let's prove that it is connecting only once. So I can go into my CloudWatch. Oops. Wrong one. What the heck? It's evil. There it is. And if I go into my logs, and let's look at that customer's get, the last log entry, scroll up, you can see here, you see that there was a connecting to MongoDB Atlas event, and all the others are just subsequent calls. Okay, so that proves that it connected only once when the container was created. All right, so we did Postman. We demoed how the first call will take a little bit more, but then it's fast. CloudWatch, monitoring with Atlas. So Atlas, of course, has built-in monitoring, alerts, all the bells and whistles to take care of MongoDB. By going here, we have real-time statistics, for example. So you can see what's happening in the cluster in the last 5 seconds. And actually, if I go back to Postman and fire a few of these guys, we should see some of that spike. There you go. So super easy to manage a MongoDB. Well, you don't even have to manage a MongoDB cluster now. It's completely done for you in MongoDB Atlas. And same with Compass. Anybody using Compass? Who's using MongoDB with Compass? Nobody? Oh, you should try Compass. There you go. So I will connect to BDLS 17 customers. The reason, so I can't connect. Why? Why do you think that is? Firewall. You're shaking. You're holding always some answers. Exactly, firewall. So I have to go into security, IP whitelist, add my current IP address, and I'll just say this is big data day LA. And if once that is done, then I will be able to connect from here to my Atlas cluster. Okay, so that's well, I'll go into Compass once it's ready. I think we should have enough time to still show the web UI. There you go. Let's try it again. And now I'm in. We're going into secondary. Who's the primary right now? Primary is 0001. Okay. And someone's streaming data, someone's streaming video, because the Wi-Fi just got slow. Yep. All right, I'll leave that up. All right, so here is a serverless web. Also, this is a cool project that a cool package that node package that was delivered by the folks at AWS. I really like what they did. Kind of reminds me of RetroPie, which, by the way, I've been playing with my son. So old school games, right? But you're running on killer tiny hardware. Now I'm going to show you a old school web UI, which is like Netscape 1995 HTML, but it's running serverless. Okay, so if I go into my AWS console and look at CloudFormation and look at this particular line here, look at the outputs. Here's my URL, and that is a web UI going against the same Atlas database that we were using. Completely running serverless. So how is that working? There is a package called AWS Service Express that lets you wrap your Node.js and Express app all inside a Lambda function. So I have my classic Node.js application, right? So you have your database connection here, you have your public images, JavaScript style sheets, you have your routes, you have your views. It's classic Node.js Express, right? And here's my application. And then in the Lambda.js function, I bring those two guys in, my app and the AWS Service Express, and literally just tie that server app against here and put it as a Lambda function. And then in Lambda, when you deploy that, there it is, it's mapped to that function. And that's it. Complete web UI, fully running serverless. So no need to manage any EC2 instances for your web apps, and no need to manage any database instances for your MongoDB. It's all completely running serverless, right? So we're done. So if you play around with Lambda, you'll know that it is completely scalable. It really scales. I mean, you just put load on it, and AWS will spin up more and more containers for you. On the Atlas side, you do have to go and change the configuration of the UI, by the way. And let me show you that. For example, the one that we created was called Cluster 0. Let's say anytime I can go and say, okay, I want to modify my cluster, and I can say I want to go from an M10, which is 2 gigs of RAM, to an M30, which is 8 gigs of RAM. Maybe I want the fastest IOPS. Maybe I want 7 host verification because I have crazy read scale, and so on and so on. And when you change your cluster, it will go and create all those instances for you, cache and so on. Okay? So that's it for my presentation. I know I'm standing between you and lunch. All the code that we showed is on my GitHub. It's Narvaez VDLA 17. There's also a link to a lot of other presentations and webinars that we've done on serverless from MongoDB. Talks from reinvent, talks from MongoDB World, and so on. And let's do the raffle. And if there's any questions, please feel free to ask. So let's see. Here we go. Who is Mayumi?
Yes.
Good one. There you go. One more. Rajesh? All right. Here we go. Any questions?
I have a question. So if I was like rolling up a dev team with like 4 devs and you wanted to kind of achieve like a continuous delivery
Okay.
of AWS functions, how would that setup look like in terms of like having a continuous build server and being able to version those APIs correctly instead of having each dev go in and upload a div?
Yeah, good point. So actually, I didn't show this in the demo, but the serverless web UI is using CloudFormation. Here it is. Here's my CloudFormation YAML, and in there you will provide your AWS account ID. Notice how I add my MongoDB Atlas cluster URI, my VPC, my security groups. So I can define all that's going to go up into the Lambda function and API gateway. So it's no different than deploying or running a continuous DevOps, CI/CD with AWS. It's no different. Okay.
And then you have to set this up once devs are just focused on delivering code and they don't really have to deal with this at all, and they can kind of push their code in.
Well, I think for that you would use any CI/CD frameworks you might be using or process, right?
Okay.
I mean, there's
Like a Hudson or something.
yeah, there's so much stuff out there.
Okay.
But I think it doesn't change from that
All
perspective.
right.
AWS code pipeline is what you want to look into.
Yeah.
Okay.
In terms of wrapping the entire Express application, like at what point would it be better to go directly to EC2 versus doing serverless, or would there be a difference?
Maybe state. Maybe if you need some form of state in your application versus that. Remember that when that container spins up, it takes a while, right? And if we're doing MongoDB connections, or you're doing some other database, or you're doing some other heavy libraries, you will pay for that the first time that's called. So I think it depends on your application. If your application is going to be used all the time and your containers will be up, it might be a good option because your containers are always hot. But if not, then you will pay for that price a little bit, right? But it's really is very simple and very easy to scale down. And I just showed a little web UI, right? But there are tons of other connectors inside AWS, like Kinesis streams and step functions and many other things that you could use. That you could also tie Lambda functions to, which is it's really complete. One more?
Yeah, about that, you mentioned that there was 2 separate containers for the different routes, and then the Python one, I think you mentioned one on another one.
Right.
Did you configure that, or is it just based on the routes? Or do you know?
No, well, the way it was done, it's really not the routes, it's the Lambda functions. So if you look in here, I have 3 functions: customers patch, customers get, customers renewals. And then, like I was saying, one function is serving these 2 routes, another function is serving these 2 routes, another function is serving this route. So it really depends on you. For example, how much functionality can you put in a single Lambda function? For example, let me show you the code, because I didn't walk through the code. Let me find my customers.
But 2 of those routes are with one, the one
Right,
here, is that
right.
the same function?
For example, exactly. So here's the get handler, and this one can handle calls that send an ID or calls that don't send an ID, which is basically a list, with customers.
2 routes now for the same
Right,
function, and
yeah,
that's how it's
exactly.
just by the function.
Yeah, there's no limitation on that.
So is every function to a container?
Yes, every function to a container. Yes. Yeah, that's where you have where you got to think about how much you put in a function and how much traffic with that function is. Yes. Okay. All right. Thank you so much.